Welcome back, Agent. Let's now discuss how to actually perform encryption and hashing with Python. Remember, in order to do the encryption, you'll need to install the cryptography library with pip install cryptography. Let's open up a Jupyter notebook. The first step to all of this is to import hashlib. So we'll start off with just hashing. And as we previously mentioned, there are a large variety of hashing algorithms available, especially cryptographic hashing, because it's a large research area of study. And if you want to see all the algorithms available in the hashlib library, this is a built-in library in Python, you can use algorithms_available, and it's an attribute off of this, where it just lists off all the libraries that are available. Keep in mind, some of these are not recommended to be used, such as like MD4, MD5, and other ones are kind of more cutting edge, maybe some of the Blake or SHA3 algorithms. Those are a little more modern than some of the other algorithms you'll see in this list. Again, here you have a lot of options to choose from, and you can even download more options if you want from the internet. For our case, we're going to use SHA3 256-bit, so the second number stands for the bits that you're using. What we're going to do is, first off, create a hash object. Let's zoom in just a little bit so we can get an idea of what we're doing here. We'll create a hash object, and you do that by calling hashlib, and then one of the methods said here. So we'll choose SHA3, so Secure Hash Algorithm version 3, 256-bit. And this was created in an open competition from the NSA. Once you've created your hash object, what you do is you update it if you want to hash a string. We will call hash object and update it with the byte string of whatever we want to hash. For example, if we want to hash hello, we have to pass in a byte string indicating there's a B at the beginning of this. And if you actually want what the digest looks like, the hex digest can be obtained by calling hex digest method off of your object. And now this is the hash version of this string hello. Now I want to show you just how different even a minor change in the string will cause the hash to be. If we just lowercased h here, that's a very minor change in the string. But if we rerun these lines, so I'm going to run this again, and instead of running this cell again, let's copy and paste this here so we can compare the previous hash to the new hash. You can see here that there's a lot, basically an entirely different hash from just lowercasing the h. And there's no way that you'd be able to go from this hash to the string. A common question that arises here is, what is the real purpose of a one-way hash function? Where would I see this in everyday life? And a really good example is when you're logging into a website that requires a password or an email. Your password needs to be secure, and it would be a pretty insecure method if Google or Facebook just stored your password as plain text. We can imagine that if you were to pass in your password as a byte string here, so maybe your password is password123, not a very good password, and you ran this, what you would not want Facebook or Google to do is to save your password as password123, because that means if their servers were ever compromised and someone was actually able to view their information, they would be able to read your password with just plain text. Instead, what Google, Facebook, and pretty much every other major company does is they will save only the hash version of your password. So on file, they'll have this hash, but they won't actually have your real password. And what they do then is when you enter your password, they run it through the hash function and then check that the hash function of your password matches the hash function of what they have on file. That way, they can still confirm that you are the correct user of the correct password without having to save your actual password on file. And then there's other even more advanced methods, which are also actually quite common now. Things like adding salt and pepper to a password, which essentially just indicates that you're adding an extra piece of string after this. So maybe Google or Facebook, they add in some little bit of salt, which is essentially just a little more extra string to your password. And they'll store that extra string somewhere else on their servers. So then your password is even more secure because they've salted it with more information. So even if someone actually is able to read for some reason your original password or the hex of it, they'll still won't be able to guess with the additional salt. So that's just another method of encrypting passwords, or I should say hashing passwords online. So that's why you would use a one-way hash. And now let's see how we can perform encryption. Again, this is just one way. We can't really go backwards from this to the actual string, but with an encryption and decryption, we will be able to go back and forth as long as we have the correct key. In order to perform encryption and decryption, make sure you've installed the cryptography library. Once you have, you'll be able to run from cryptography, let's make sure we spelled this right, from cryptography.fernet import fernet with a capital F. And then the first step is to actually generate a key. Later on, we'll show you how to create your own keys, but it's a lot more secure if you allow the cryptography library to generate a key. So to do that, you'll call the generate key method off of this. And then you will have some hashed byte string here. And now that is your key. So this is a cryptographically executed key. And later on, we'll see how to make our own based off of some seed string. Once you have the key, what you can do is create a cipher. We'll create a cipher, and we pass in that key into this fernet, and we create this cipher object. And now it's actually quite simple. You just take whatever text you want, and off of your cipher object, you call encrypt, and you pass in the byte string of your text, such as hello, are you there? And it will return back the encrypted version. So this is what you can publicly send around, and hopefully no one will be able to actually infer what is the actual message behind this encrypted version of it. Then if you're on the other end, what you do is you create your own cipher. So let's say the person's on the other computer, they create another cipher. What they will need to know is this secret key. So that's kind of the challenge of encryption and decryption. You have to somehow get this securely to the other user. And then we have your other cipher. And what we can do now is from other cipher, we can call decrypt and then pass in the encrypted message here. So we'll copy this. Notice again, it's a byte string starting with a B outside of that quote. And we pass in this whole thing. And if we decrypt it, we get back, hello, are you there? All right, so we just mentioned that in general, you should try to generate keys from this library to make sure they're cryptographically secure. But a lot of times it's easier if the recipient on the other end has some sort of basic string to go off of. So let's now show you how you can create a custom key. Again, we don't recommend you do this unless you absolutely have to. We'll create a key word for our custom string. So let's say the custom string is just 1, 2, 3. So that's our keyword. Note it's a byte string, so notice the B there. So we have our custom keyword string, 1, 2, 3. We now need to use hashing to actually turn it into a hash of base 64, basically this format that the fernet function is going to be able to use. So we will say key is equal to, we'll call hash lib, and we will call the secure hash algorithm version 3, 256-bit, and we will pass in our keyword, essentially that B123. And now we have a key. So we have this hashed object, and we can grab the actual digest off of this. And we have this digest, and this is actually still not in the format that the fernet object expects. To actually get it in the format, we need to encode it to base 64. So to do that, we will import base 64 and say key bytes is equal to key.digest, essentially what we had up here. Run that, and then say your fernet key is equal to base 64, and the method call here is quite a long one, so I recommend using tab complete, and say URL safe b64 encode. So that's E for encode. So we're going to encode these key bytes, what we got out here. And once you encode it, the key should be in the format that we expect, something that looks like this. And that's how you can start off with a keyword that is easy to share and then some sort of agreed upon hashing algorithm, and eventually you can get back out a key that will work with the cryptography library. This is not as secure of a method, but it still works. So once you have this key, what you do is you can create your own custom cipher and then pass in that key when you're creating it. We'll say for net key, run that, and using that custom cipher, you can then encrypt any message you want, such as, well, let's make sure it's a byte string. Hello. We get back that encryption, and then we can call custom cipher and decrypt it again. So we'll copy and paste this. And we get back hello. All right. Those are really all the basics you need to know about hashing, encryption, and decryption. Let's have a very quick overview of what we just covered. So starting from the top, to do basic hashing, you can just call the Python's built-in hash library. There's lots of algorithms available. So you can see here, not all of them are recommended. Some of them have been deemed insecure. But something you can go for right now is SH3 256-bit. That's still deemed secure. And you can then update a byte string and get back its hex digest if you want the one-way hash. And again, to make it clear, if you do even a minor change on this string, you'll get back a completely different hash because it's cryptographically secure. If you want to perform encryption, you use the cryptography library, and you can either generate keys from the library itself and then use those keys to create ciphers, and off the cipher say encrypt or decrypt. And as an alternative to using generate key, you can essentially create your own key based off some root keyword and some agreed upon hashing algorithm. So you decide on the keyword byte string you're going to use and the hash algorithm you'll also use, pass that keyword into that hash algorithm, then grab that digest and using the built-in base64 library, encode it into the same format that the cipher will expect, which is this right here, then pass in into Fernet that key, you'll get back your custom cipher, and you'll be able to encrypt or decrypt messages. That's it. Best of luck on your next mission, agent.